Good afternoon, or whatever it is, in whatever time zone you might be out there in internet land. And welcome to the final set of presentations for Vector Hack number 3, live and direct from Šibenik, Croatia. We have a whole program today that has a very specific theme, as the other couple of days had. The first day we talked very much about the history of different sorts of electronic instruments, and in particular the practices of several amazing women and one man that were using these instruments and developing the field. In the second day we talked about software implementations of different sorts of vector and video practices that are very influenced by these practices from the 1960s and the 1970s that we discussed on the first day. And now finally we've come around and we're going to be talking about hardware and different aspects of how these techniques become embodied within a device, within a machine, and some aspects of how to handle those machines as well. So we will, in order, we will have Bernhard Rasinger, who will be giving us a talk about laser safety. Then Darko Fritz and Marušić Klif, sitting next to me here now, will be talking about a particular hardware scan processor that Klif developed for Fritz's film Imaginary Future, Tourism. Arto Chydenius from Finland will be talking about his hardware vector synthesizer, Voltage. And finally, Andrew Duff will enlighten us to the appeal of the oscillographic image, before we adjourn to a small panel talk where we will also be joined by the eminent Joost Rekveld. Bernhard Rasinger is an engineer, visual sound artist, and co-founder of the Arts Association New York, Vienna. He's a regular guest at international experimental music festivals, music fairs, and those strange things that we know as soldering workshops. And very relevant to this particular presentation, Bernhard is also a licensed laser safety officer in the country of Austria. His work combines state-of-the-art laser technology and modular synthesizers to create lucidly hypnotic live audiovisual performances, where what you see is what you hear. Bernhard.
Thank you, Derek, and welcome. I will be your laser safety officer for this afternoon, and bear with me. I hope to make this as interesting as possible. It is a rather dry subject, and but we have a laser projector here. So my task as a laser safety officer would be to make sure that everybody is safe. It's kind of to raise the awareness and let people know there's a laser projector for visible display in the room, and that is dangerous for the eyes. It's a laser class 4, which we will go through the classes later a little bit. And so just so you know, please don't step anywhere in front of the laser. These gentlemen over there are safe. They have been warned. They are outside of the laser safety zone, and I will turn the laser on for a quick moment so you can see the light, which is amazing, and then we'll show you the laser safety zone. So I'll turn it on now. You will see that the projector is here. It sends out the light. And then, this is obviously not a very safe setup. Also for a purpose of demonstration, this is rather low. This should be over 2.70 meters, but since I play live shows with this, there is often the problem of space confinement, small stages, people on stage, other artists, technicians, photographers. So there's some guidelines I will talk you through. So this is the laser. It's mapped to the screen. It won't leave the screen anywhere. It's not going to scan you, so you will be safe sitting in the audience. And so we have defined a safe space. So if Klif and Derek stay where they are, don't stand up. everybody would be safe. In case somebody should go crazy and say like, "You laser," and jump around, there is a kill switch, the laser is gone, and it also has a key, so you would have to have the key to take it back into operation. There's a little delay. Okay, so it's back up, and but let's start with the presentation. So I use this modular synthesizer to show waveforms on screen if I play solo. Sometimes I also make visuals for other artists. You can see that the laser is now responding to the microphone. I get a feed into the modular synthesizer, and in that case, you can see there is also an envelope follower that kind of follows the shape of the signal and turns the brightness of the projector on and off. So if I talk, it becomes bright, and if there's no voice, then it becomes dark again. I'll turn this off. So this is one of the methods that I use if I visualize sound for other artists, and just to make it safe and not burn any holes, I have this envelope follower circuit following the signal. But let's jump into the more interesting stuff now. So laser safety, I'm a laser safety officer. You have been informed that there is a hazardous laser emitting device in the room. And let me put the next slide, maybe. Sorry, this here. So there is this joke about don't stare into the laser with your remaining eye because the other one is already gone. This is, a little bit funny, but it's actually also quite serious. These projectors are not toys, and the accessibility has really become quite, or this technology has become quite accessible in the last 20 years. There used to be giant devices weighing up to a ton with cooling devices and gas emitting resonators. This is like a shoebox. It weighs 5 kilos, so you can take it easily into a room, put it and do crazy stuff with it and be irresponsible. So as funny as this might seem, it is dangerous for the eyes. So bear with me, and we'll make sure that nobody gets hurt. This one is at this conference very much what resonated with me very much is how you can use technology and how we use this technology in our field of work, since there's also military applications, and you can use lasers to guide or target weapon systems. And this resonates with me that I try to use the laser technology to bring happiness into people's lives, and by flickering colorful images. And I think that's a very noble thing to do, and not use it for destructive thing. This is like a clip from Star Wars movie. It's within there's a laser pointer there, so there's a resonator, or like these people are obviously not very safe because they stand within the resonator of the laser. It's probably not very safe in there, but it's a science fiction movie, so. Okay, so lasers have different applications. There's the scientific, medical, military, industrial, and commercial. And with this laser projector, this is a show laser projector within the visible wavelength of the spectrum, of the electromagnetic spectrum. And so this is from Wikipedia. So with show lasers, we kind of dance within the entertainment and recreation section of application. And so this is like laser lighting accompanying music concerts, or you can play laser tag, or like there's this laser harp that Jean-Michel Jarre maybe used, and there's also light sources in these kind of cinema projectors. So let's have a look. So this would be a scientific application to create a virtual star to focus for these telescopes. Then you have medical application. You can see here these doctors, they have laser safety goggles on, because obviously, apparently, this laser device emits visible radiation, and it would hurt their eyes. And if they work with this radiation every day, this is a common, this is an application or a method how to secure your eyes from damage. Then you have military. I think this, which is not so cool, but I think they are trying to shoot down drones. These lasers are quite powerful, and yeah, they're also quite scary. And then you have industrial applications. This is a heat laser. So the principle is always the same, like the laser is a kind of radiation, and it radiates at different wavelengths of the electromagnetic spectrum. This laser is the same safety class as this laser, safety class 4, which is the most dangerous. And here you can see that it cuts through, or this particular laser is a heat laser. It cuts through some steel that is about 1 centimeter thick. And the same safety class would be this. It can't cut through steel, but it can damage your eyes. This laser could potentially set things on fire or burn your skin. So, so this is the entertainment side. You can see also here, already, there is a stage, and the laser projectors, just for visual display or like make this nice light effect, is shooting away from the stage into the direction of the audience, but above the audience, so nobody should get this in the eye. And so you have to make sure, and you also see people at the concert having their phones up. So there's this threshold that if you set up a laser in a space like this, it should be above 2 meters and 70. So the lowest beam should not be lower than 2 meters 70, and which if I think, like I'm 180, if I like this would be 2 meters, and maybe so if I stretch myself, have a phone, I would have to step onto a chair to be able to deflect the laser with a phone, which is like a reflective surface. So that, if I set this up this way, it wouldn't leave me with very much space to project the laser show on. So there are different methods. So now we kind of have a laser safety zone. I'm apparently walking in and out of the laser safety zone, but the laser is off, and so I can be safe. Let's go on. So laser is radiation. It's an acronym for light amplification by stimulated emission of radiation, in case you have wondered. So, and just very quickly, the laser principle you have, there is like a medium, and then you see something like a pump source. So it puts energy into this laser medium, and then there's an optical resonator. And so this laser medium is being excited by energy, and then, this laser medium forms another state of energy. Radiation is being emitted, and and the laser cavity has a highly reflective mirror in the back and a partially reflective mirror at the front. So this would be the end where the laser beam would then, or the laser radiation would then be emitted. just I'm going to I don't want to bore you with too much technical details. So the laser has certain characteristics, and it is it has this characteristics of coherence. So all the wave, so it's an electromagnetic wave, and we can perceive this in forms of different phenomena, like for example light. So so all the waves, they oscillate in phase. You would say like incoherent light would be different waves oscillating at different frequencies, and so like over the whole spectrum, and also with different phase alignments. And so the laser is phase aligned, so it oscillates phase synced, and also it oscillates at a certain frequency. So that's why the color that we perceive is so intense, or it's a very precise color. And then it's the directionality. It's like it's directed. It's not diffuse like a light bulb that lights in all directions, but it's very, very pointy. It's monochromatic. That's so that's like the color is like very precise, and it has high intensity. And you can see here like an intensity graph. So it accumulates all the light intensity on a very small dot. Apparently, like if you're closer to the laser, like the laser beam is not perfect, so it's not a perfect parallel beam. It diverts a little bit, and like with the distance, it becomes bigger and bigger. So the further you're away from the beam, the less intense the beam will be. And next slide. So we are talking about the electromagnetic spectrum. We are dealing with a laser that is within the visible spectrum. Within the we saw like different applications. For example, this heat laser would be like infrared. It would be the same principle. It would just oscillate at a different frequency and not be visible, but it would, be a heat beam and be able to cut through steel. Then you also have ultraviolet like lasers. And here you can see that, light stimulates in our eyes, stimulates a reaction that, that we can perceive as an image that our brain interprets. That's what we see. And so it is dangerous for us to look at a laser beam, because it will travel through the light and hit in the back of our eye. So normal vision looks like this. Light enters the eye through a lens, so it's an optical device, and it will try to focus whatever it looks at the back of the eye to make an image. And since the beams are in the visible electromagnetic spectrum, so the light with all its intensity will travel through the lens, be focused, and then potentially destroy the nerve tissue, which is called the retina, and this is not repairable. So this is nerve tissue. So basically, the potential to blind somebody with this permanently is very high, and that's why it's so dangerous. You should take care and not, or like employ a laser safety officer if you have one of these lasers. So there's another one of these, and this is a slide. I don't want to go into the numbers so much, but it's what I said. If you projected a laser into the eye, it would be focused, and the intensity at the back of the eyeball would be extremely high, in comparison to like if you just see regular light, because there's already so much intensity in the beam, and it's just a very focused source of energy. So let's go on. So there's different laser classifications. There are some lasers, maybe, you know, like you have a laser in if you remember like old CD-ROM drives, and it also like these devices, if there's a laser, there should be a sticker on it saying like this is laser class 1, laser class 2. So you have different laser classes, and depending on which laser class it is, it's more dangerous for the eye or for the skin. As I mentioned, like there are lasers. I have this laser pointer, and here it says this is laser class 2, which like the laser class 1 lasers, you can potentially like light into your eye and there shouldn't be any damage. With laser class 2, you need an optical device, like maybe wearing glasses to focus the beam more. And but still, like a safety measurement would be that your eye would close, because it's uncomfortable for the eye to look at really bright light. So it would close within a quarter of a like 250 millisecond, a quarter of a second, and you know, save yourself from damage. So this is laser class 1. Laser class 2, you're still safe with the eye. And then laser class 3, there's like a there's the wattage of like how strong these lasers are, like how much light they emit, and so it's very fast. Like this is 500 milliwatt beam output power, which doesn't seem like a lot. This projector has 7 watts or 7.5 watts, so it's like outside of this scale, and it's certainly within this like very dangerous laser class. And so you can easily have access to very dangerous equipment very fast. And so my plea to you is, if you get into lasers, if you work with lasers, be safe. Don't take this on the light shoulder. You can really hurt somebody permanently, or be hurt yourself even now. So, but let's, you know, this is, so then you have like these safety banners. It would, like this, there's one on this projector which would say laser class 4, and then it warns you avoid eye or skin exposure, because also you can burn the skin, you can have permanent eye damage, and you shouldn't, like, the worst case scenario is if there would be a standing beam, and so it doesn't move, so there's like constant energy like bundled in one beam, and it would hit you in the eye directly. This is the worst case scenario. So like setting up this projector like that it shoots onto the screen is quite safe, since there's no audience being scanned. If I set it up on the other side of the room and scanned the audience, even like did a scan line, you would look directly into the beam, which would be very dangerous. And so there's potential dangers. You can hurt yourself. Like I'm the laser safety officer, but still, you know, I'm standing here. If I turn this on, I could, you know, I can endanger myself. You can endanger others. The audience, for example, if you play shows, or technicians that set up. During the setup, we had a small, like Derek was also so kind to say, like, yeah, inform everyone, or not just people on stage, but like people are running around, putting cables up, maybe they have something else in mind. And then while setting up the projector on the screen, it can be already dangerous, because even though you're not in the audience. Then, you know, dangers to animals. There's like if you have this laser pointer, you know, these videos with cats will chase them. You could potentially blind your cat or someone's cat, and then this cat might have a blind spot, run over the street and be hit by a car because it doesn't see so well. Then danger to objects. You can, you know, like if you have a standing beam, this projector can already burn a hole, or like if you held up a paper, it would probably light this paper up. and this paper would start to burn. It's like the spot killer that everybody's afraid of, like burning the phosphor in Vectrex screens and oscilloscopes. You can potentially also burn holes into the screen or into any burning material, so there's the hazard of setting things on fire, like setting a fire. And very important, thank you also for reminding me yesterday. One of the technicians said they have experience with if you shot the laser into like one of these projectors, so it would be set up making a scan show over the audience, but there's like a data projector like this beam up there, and it would hit the optic and then hit the sensor that makes the image. You could damage the sensor as well as you can also damage the sensor of a digital camera, and then for a photographer this is not cool, and you have like burn marks in the camera. So there's danger to traffic if you do beam shows outside, next to a road. People can be distracted and maybe like, oh look, there's a laser show, and create a crash. So it's just to raise the awareness. If you deal with lasers, there are potential dangers everywhere. You could also like shoot up in the air. There's very high power lasers, and you could distract airplanes. And so there are some measurements. As I said, the laser safety officer, you have to employ one if you operate a laser above laser class 3R, which is very quickly. You would, if you were like an operation, a company cutting steel with a laser, you are obliged to employ a laser safety officer that tells everyone that this is safe. Same as here, like I would be the laser operator, and so I would, in this case, I employ myself. Make sure that nobody gets hurt, because by the end of the day, I'm the one responsible for any damage that occurs if I bring the laser, or if you bring the laser to a venue and make a show. By the end of the day, you are responsible for anything that happens. So be safe. It's like an easy way is to evaluate the workspace, like how many people are there, like what, and do some risk assessment. Is there like are there curtains that can light on fire? Can I make a laser safety zone? How high is the space? Like in case of these beam shows, the higher the room is, the safer it can be, because you could potentially put the projector up here on the rig and then have it shoot down, and then you would be safe. Only if you stood here you would get the beam, but then the operator can always see the screen and hit the emergency button if somebody would go into the laser safety zone. Then a big part is also, like, if you do beam shows, reflective material. You could see maybe all these lights up there. If you hit those, or if you hit if there was a disco ball, the light would be reflected and potentially could go on the disco ball and hit somebody's eyes back in the audience. So you have to make sure that you don't hit any of those, or do some digital masking, or just keep the laser within the screen and not exceed this safety area. Then there's laser safety goggles. We saw those already. They don't really work well on beam shows because they blank out the light. They are like monochromatic filters, and so when you put them on, you don't see anything anymore. So it's really hard to work. But in case if you in the medical application, it made absolute sense. And then there's this interlock system, which basically there's a 12-volt loop going through the projector. So the projector sends out a voltage and it goes through a switch coming back to the projector. If you break that switch, the projector knows, I should turn off. And it, for example, it can go through this laser disable button, or it can go through like a light sensor, like a trip. And if you walk through this trip wire, it could also turn off. And you have to, then it's latched, and you would have to like turn it on by hand, just to make sure that nobody's in that area. So I talked about this a little bit before. Who is responsible and who is liable? And like if you are asked as an artist to play a light show, then it's usually also quite difficult to, if it's a big production. I was once playing a show for the Austrian TV company, and they said, well, I have to employ someone else to make a report that I did everything safe. So just being a laser safety officer is not enough, because they, in the past, people like to go to shows and then maybe see the laser show and say like, I have some eye damage and here's my lawyer. There's a big company involved, so they try to scam big companies, and they were afraid of this. So they were extra safe and said, we believe you that you can do this safe, but we want signature and stamp from an external, like Gutachter, like a professional that, says, yes, this is really like, there's a signature, I'm approved official that can, approve this, so there's an external approver. And then often these people cost money, and then the production might not cover the cost. So it gets more and more difficult if, like, the bigger the venues and the more people are in a space. There's also another story, like there's a synthesizer fair in Berlin happening every year called the Super Booth, and they have asked me to play there, or I've played there already twice, and now they've become a little bit paranoid about like if something should happen, I would have to have an insurance to cover like an audience of 400 people. So like the worst case scenario is that 400 people go home with an eye damage. So I have to have as an operator of this laser device, have to have an insurance that would cover this worst case scenario. And so this insurance would cost so much money that for me as an artist that it would make sense to play this gig. So basically they're saying, sorry, but we don't want to take any risk, and if you can't be insured, then our insurance doesn't allow you to play. And then it's like this cascade of like who is liable and who is responsible, and then if nobody wants to be responsible, nothing happens. So yeah, so you have these different players within the game. There's also like a meme, just to lighten this up. It's me at camp. We're shooting the lasers into a tree, and then everybody's amazed by this scan show in the tree, and like the birds maybe don't like it so much. They wake up blinded, and which is not cool. But and then this was a joke, like the vector hack. Some vector hack merchandise. Don't be an idiot. If you deal with lasers, be aware. I mean, this guy was maybe hopping around, but he's also just randomly from the internet wearing an eye patch. So the basic message is: be aware that this is dangerous. Don't be careless. Be responsible. Know what you're doing. If you play with lasers, or if you see that somebody is also not acting responsibly, maybe make them aware. Say, okay, this is dangerous. Maybe we should do this and this. And I remember Derek the other day. He was like taking a chair with reflective legs of the setup we were shooting against the wall. He was very aware, and I thank you for this. So this would conclude the talk. I don't know if there's some extra time, and maybe we can go through the images. I have some images from setups that I have acquired through some years, and we can just see how safe they are and like what maybe the thought was behind those.
Is this like an audience interactive quiz? Spot the violation.
Spot the violation, yes. Or I also like encourage you if there are questions or if there's something. I hope this was not too didn't bore you too much with this safety thing, but it is, for me, it is like very present. If I play shows, I have to think about this. I have to make this safe. I encourage you, if you go into the laser game, to be aware of this and also make it safe. So here I make like visuals for a drummer, a good friend of mine. So, he's on stage and the laser is above him, and, he sits down, but in case he stands up, he could potentially have this, beam in his eyes. And so you need to make sure that he knows to not stand up, and it's also masked that it doesn't hit him while he's sitting playing. And so this is a potential risk that, the audience is not being harmed, but he as an artist on stage could be harmed. This is me shooting into this direction. What you can see here, the photographer taking this picture went in front of the projector, so like he could already, like here you see the projector. There's also like this caution warning sign, and so this is where the beam would come out, and so like the photographer could potentially, like, usually they're like everywhere, they want to take the best picture, so they move around, and if they don't know, if you don't tell them before that this is dangerous, they might damage the camera, they might damage their eyes. So this is me also doing visuals from the sides, and here the stage was here, so the artist would stand here and the laser was up. I don't know if you can see the beams. So since the laser was up, like it was, I just had to tell the people not to step behind this table, so there was a barrier, not so people couldn't go into this laser beam here. Then here, this is maybe difficult to see. It's in a large industrial space. People are standing here and everything is happening above their heads, so nobody can get into the beam here. So it's just safe because it's high up. Then here, like this was is from the other side of this one picture. You could see, like, I made sure that nobody would walk here. People were behind me, they would see the same thing, and if anybody walked in front, I could, as the operator, turn off immediately also. So this is a similar situation. So the projector is here in the middle, nobody's in the front, and even though it's, you could potentially walk in there and, get the beam into your eyes, not safe to walk there, but since I'm the operator, it's always visible to me. It's like simple things like this. Here you have, this was the visual part where the laser was, you see the beams coming from the top. And there was actually an incident, so you see here, the photographer wanted to take the picture of the artist, and you could see this beam. I had to like stop the show and say like, hey, you're standing quite close to the danger zone, so maybe come to the front, because she got very excited to take a cool picture, and also the beams looked very nice. So I had to re-warn her and say like, hey, this is super dangerous for your eyes, this is super dangerous for your camera, and don't risk anything, please. And then I continued with the show afterwards. And this was the same thing. But he was safe because, even though, like, if I would shoot from the front, he would get in his eyes, but it was kind of shot from the top, and there was enough space to the wall. Here you can see my friend, drummer, Lucas, and we did some tests for a video, and we were only shooting the green, and he has, like, laser safety goggles on, so like he was also like inside the circle, and just to be safe, he had these goggles on, and they, you know, then do not damage any eyes. This is a similar situation. So I think here I blanked out this part because the drummer was on a riser, and I had to inform the musicians that, you know, if they walk too far to the back, it's a potential danger. And so there were 3 projections on the side and on the stage, and you can see one projector is up here, so the angle allows me to kind of shoot over the heads. Only like if they would stand really at the very screen, that it would be dangerous for them. But they had amplifiers in the back, and the drummer had a riser, so I had to like cut a piece out here with a digital masking system and to make him safe if he gets up. And this is from the same gig, and the audience was sitting here, and then I had like a external professional come in to measure this and say like, this needs to be 2.70 meters, but you know, this is not a rock concert where people stand and maybe take other people on their shoulders and wave around, like and put their phones out and have reflective surfaces. So like all these measurements, they have some kind of thought behind, and some of these measurements make sense, some maybe don't, or like you can be very strict, but also you can be so strict that then the show can't happen. And so it needs to be within measure, but it needs to be safe by the end of the day. This is also, you can just see that, you know, these musicians and technicians and photographers being on stage would be in potential danger. Yeah, I would like to conclude this talk. Maybe there are questions. Let's see the laser again. You can also make different colors. So the white beam, let's see like a blue one, and like a red one. So this is a RGB system. It has 3 diodes. You can see that this setup. Also, this projector is on a stand, and it's, you know, this could tip over. Usually, it's better to mount it on a fixed location. I mean, there's a bag of sand here, and I also did this like a bit wobbly, so you could see that, you know, if I tripped over this fence, this could tip over and be a potential hazard. Also, something to keep in mind. So it's always good to put something on the rig and be safe. And with this, if there are any questions, now is the time, and I hope this was a little bit informative for working with lasers.
Vielen Dank.
Thank you.
Questions from our studio or our internet audience? Yeah, hold on. I'll run to you. Duff, his hand is sweeping into the air.
Hi, thank you very much for that. I wonder at what point you became a safety officer with it. Was there oh, this is cool, I'm going to do it, and then, there needs to be some safety here?
Yeah, I started doing this. I started creating this system in 2011, and I had no clue about lasers. But the more I was asking around, and I talked to people and said like, "Hey, I want to do this thing with the laser, and it's going to be amazing." And usually the response was, "But aren't lasers super dangerous? And you know, they're expensive and dangerous. How are you going to do this?" And then I started reading about the dangers, and then I did this laser safety course in 2012. So I got my first laser, and also, like if you read about, or maybe I didn't know well enough how dangerous this is, and so I did the course, and I'm happy I did, because the more you know, the safer you can be, and then you say like, this is dangerous because, like this is how I can prevent these dangers. And yeah, just if nobody tells you this is dangerous, then you might not know until it's too late. So I guess I was lucky that people told me like, isn't laser light really dangerous? And then I was like, maybe I should find out. And then I started reading online, and I did the course. And funny enough, I was in a course. I was the only person doing laser shows, and there were 10 guys with, there was in Linz, which is a town with a lot of steel work, and they were all employed by steel factories, and they had these giant laser cutters. So for them it was another hazard, but the same machine, like the same laser principle. So yeah, I hope this answers the question.
Great. Any other questions here? Yes, Kevin.
Thank you. I was really interested when you showed the blanking, right? And I was wondering if there is any kind of real-time auto blanking. So every time some kind of camera detects people in the stage, the laser will never point to them. And if you have seen something like that, and if you think if it's going to be useful.
I mean, I use a system. Let's see if I can connect this now. Ba-ba-bum. Thank you for the question. It's a very good question. I have a system that is now not connecting. Yeah, hit the button. Hit the button. I can show you a little bit here. So let's go into this system. It's so in this projector there is a DSP inside. This is like a high-class projector, and it's very easy to work with. I can, I showed you the masking before, which is good if the projector is not straight, so it can this digital geometric transformation, even though it's not straight onto the screen, it can make a circle, for example, appear straight, even though it would be distorted from this angle. So there's the DSP compensating for this, and there's also a safety mask that I can show you. So edit the mask and preview it. Just have to be careful. Now I'm drawing a mask. Let's see if it's showing up. So I can draw different masks here. So if for example there was a disco ball up there, I could, but this is within the system. I could say okay, there's a disco ball, don't go here, and there's maybe a light or a window. This is a bit out of. Don't go here. Don't go here. Every time you cross this window, do blank it out. So and then you have you can see that these two elements are now blanked out, and the laser beam won't hit. But this is within the system. I'm sure you could probably with software write a script like this, or I mean, this is quite a elaborate system, and that allows you to be quite safe like this. And if there was somebody on stage and say okay, somebody's standing, don't go below this, and they really thought about this safety issue also. And I'm lucky to have this product and be able to work with this and make it safe. But there's things like this. I hope this.
I think maybe another answer to your question, because you were talking about maybe a camera that would be able to artificially, intelligently detect if there was a person there.
Okay.
However, do you want to trust that to a machine? Would be a really valid question. Most laser safety protocols in most countries are really strict about a human monitoring the situation, that you can't just put a powerful laser doing something on a building and just leave it unattended or something like that. There should be a human element that's actually an integral part of the safety loop there. A question from the YouTube for Bernhard. which is a little bit less about laser safety, but it might be good to mention as well, from Egle. Egle asks, what are the most common softwares that somebody might start looking at to control a laser if they don't have a modular the way that you control your laser?
Yeah, that's a very good question. I'm not so knowledgeable about this. I know that people work with Macs and they work with different sorts of vector-based. They work with PD. I think you do your patches in PD. So anything that can draw vectors as a software, and then if you have a digital to audio like analog converter, you could potentially connect any software to a projector through the ILDE interface. As I'm not using software so much, I'm maybe the wrong person to ask, but
I know that there is a simple software package for Macs or for Mac OS that is a laser drawing software. Klif, you've been experimenting with a few.
Because on one hand I was testing this experimental approaches, but I've been in a few situations where I actually needed to make kind of more standard content for laser show, and I was testing some of Beyond and show what's the baby Beyond called, show something. Beyond is commercial company. I find those softwares, they're both expensive and they look like DOS programs from 90s. So very difficult to come into that. And recently Med Laser was added as addition to Med Mapper. And that's modern software. It has all safety features. It's not too expensive. And really it's like everything you need if you want. Also it's really easy to do video mapping and laser mapping. And it does all the safe zone stuff. Like really you can draw masks, you can do everything. And I really, if people are interested, it's kind of good, I would say. I'm not aware of any other software that is not completely amateur. There are some tiny packages, but it's kind of very clunky, and certainly it's worth experimenting. But if you want to actually do the job and listen to any of the stuff that you said, I would say that kind of Med Laser is the only package that I'm aware of that is within the reach of young people, VJs.
I never worked with this. I know some people also do laser work on Touch Designer.
Yeah, Touch Designer is a really interesting option because the licensing for Touch Designer is based on the video output resolution that you want to use, and the laser output of it is completely outside of that. Actually, you can get everything that you would want to do with a laser on the free version of Touch Designer. So that's a kind of a way that they might hook you in a little bit. Yeah, hold on. I'm going to run back with the microphone to you.
There is, however, a thing called modulaser, which is like that. So it's like 3 oscillators, and it does a bunch of rotation, and it's got a bunch of safety features as well implemented into it. It's kind of... and I think in total that's like $100.
And there was also this thing, the Maxwell. I forgot about those. Maxwell is very similar to Modulaser.
Okay.
I think it was made in actually Max. Modulaser is really interesting too.
Yeah, it's kind of the software equivalent to the Radiator actually, because it's like 3 oscillators and it's got a bunch of presets, a bunch of like rotational things, and I don't know. I for some reason, like, I didn't insist on bringing my Radiator to Europe, which I probably should have. This would have been perfect, but I felt like having Modulaser on my computer is like a good option, and it recognizes like all kinds of DACs and all kinds of things externally, and it's really, really easy to use. But yeah, all kinds of safety features implemented as well. Everything that you've talked about, Bernhard. It's all there, and it's like maybe $150 like max. So yeah, modular option.
Yeah, great, thanks. That was actually the Mac OS package that I was thinking about. This is not a paid product endorsement. Any more questions from the audience? Any more questions from the Ghost virtual audience? All right. There is. Harvoja.
Thank you. for the presentation. What happens if our eye gets hit by invisible spectrum of the light?
So that's a very good question. This was covered in the laser safety officer training. Since I was, attending it with a lot of people who worked with heat lasers. So the heat laser is out of the visible spectrum, like we perceive, like heat from the sun, like infrared radiation, and which is has a longer wavelength than the visible light. And it would be, if you get hit by like something that is very hot, or like if you had like diffuse radiation even hitting you from a laser, you could burn your skin. It wouldn't, however, be dangerous for your eyes, because like the properties of this wavelength, of the infrared wavelength radiation, would be absorbed by the very first layer of your eye. It wouldn't go through the eyeball and hit the retina, so it wouldn't make any permanent damage in your eye. It would burn your eye and it would like get milky, but this part of the eye you can actually repair. So it wouldn't be dangerous for the eyes. It would just be very uncomfortable. Like it would burn your skin and maybe like cause severe skin burning, and or maybe light your clothes on fire. So that's it's another hazard. It's more like burning the skin, and but it's again it cuts steel with heat. So but it's the same laser class. There's no other laser class. So the laser classes, laser class 4 is also these heat lasers that cut through this like 2 centimeter thick steel plates, are the same laser class, and it affects the tissue and material in a different way, because it absorbs, or different materials absorb radiation in a different manner.
A UV laser, on the other hand, is extremely hazardous to your eye, for the reasons that you showed in your electromagnetic spectrum, that
Yes.
UVA and UVB will definitely burn you the same way you get a sunburn. And it's also more dangerous in the sense that your blink reflex won't kick in, or you won't look away from it.
Yes.
Hold on, you get the microphone if you're talking. Follow the rules, Evan.
Sorry about that. I have a really like painful example of literally working with UV light and lasers. Maybe like a year and a half ago, 2 years ago, I got into cyanotypes, or making cyanotype art, or like laser art with cyanotypes, and the cyanotype, the chemical, only responds to UV light output from a laser projector. And honestly, in all reality, it is kind of one of those weird ones that is really difficult for your eye to pick, or for my eyes to pick up on. And I didn't really know if it was exposing long enough, and I actually like let the beam sit very, very still for all of a fraction of a second, not even a second. And in the process of making this one particular cyanotype, I literally burnt the paper. It was really, the only reason I saw the paper burning was this like kind of minute like red light emitting from the paper,
And it starts
and
smoking. No?
literally within like fractions of a second, I just like shut the laser off, ran to the bathroom to develop the cyanotype print, and like it made something really, really cool. It made something very, very organic, but I mean, making cyanotypes with like laser stuff is really beautiful, but also like very, very dangerous, especially if you're doing this in your home.
Yes.
And yeah, you don't want to set your house on fire making art. I mean, do whatever the fuck you want, but like just honestly avoid doing that altogether. So it's kind of why I don't make cyanotypes anymore.
But
so
you're responsible with it.
yeah, of course, yeah, absolutely. So I should also note that I burnt the paper, or I started this fire using a pure data patch from Derek. So yeah, word to the wise.
All right, you're cut off now. That was, you were probably using the not laser patches, because the laser patches actually do have some spotular things in them. But yeah, it's nice to get this kind of feedback from out in the world. I think that just about wraps up the time that we have. Thank you, Bernhard. Give him some round of applause in the studio. Give him the avalanche of emojis on YouTube. And we will take a short break. We will come back with Klif and Darko, and they will talk about scan processing and Darko's film, which some of you were able to see here screened last night. We take 0.87 cigarette break. I'd say 10 minutes. You can let me know when we're good. We're good. We're there. Hi. We are back. We're back in Šibenik, and we're back on the YouTube, and we are back with Darko Fritz in Korčula, I believe. Or are you in Zagreb? Korčula, great. So just down the coast. And we are here with another human being who I think some of you might be familiar with, Ivan Klif. Ivan Marušić Klif. I have completely lost my notes here. 1 second. There we go. All right. Let's introduce our two speakers. Darko Fritz is an artist, curator, and researcher investigating the use of technology in culture. His curatorial work and research on new tendencies and early digital art has earned international acclaim. Fritz is the founder and programmer of the Gray Area Space for Contemporary and Media Art since 2006. Ivan Marušić Klif is an artist, educator, and founder of the Vector Hack Festival, which we are all hanging out at right now, thanks to the generosity. Well, I would say the main driving engine, but we can argue about this over some beers later. All right. Okay. He is one of the main engines behind the festival where we are sitting now. And I personally, when I first visited Zagreb in 2000, and I was asking around who actually makes electronic art, Klif was often the only person anybody mentioned, so we've been aware of each other for quite some time. His field of interest includes light installations, kinetic objects, music and sound for theater, interactive video installations, and performance art. Together, Darko and Klif will be talking about Darko's film, Imaginary Future, tourism, and in particular, for the relevance of this panel, we're going to be talking about a scan processing VGA implementation, which Klif used to create some of the very striking visual effects in Darko's film. I'm going to turn the floor over to Darko now, and I believe you're going to talk a little bit about the Imaginary Future project. Yeah, you're good. Da.
Thank you, Darko. Hello. Perhaps, yeah, bring a bit of contrast. So I have to make this short, and first I have to start my timer to have some idea of what's going on. And hopefully this will go a bit better than my previous vector hack presentation, as I started stating on my performance on the first vector hack, presenting something and organizing festival at the same time is actually quite a bad idea. But also this year it has to do with our theme of demons of machines and their own life. I'll get to that part later, but it works, so it's amazing. Let me see if I can get the photo. Yeah, okay. Just like no, no. Okay, Fritz, goodbye. No, the image is flickering, and but we'll get to demons later. So this is all some sort of Ratetra talk. We keep coming to that, back to that, and Vazulkas. My first conscious contact with Ratetra was actually when Stajna Vazulka visited Zagreb. She was invited by late Professor Galeta to Academy of Fine Arts. She brought her little camera and she was showing. I was actually teaching, collaborating there at the time. And can you turn Fritz off, because I think we're maybe there is some double.
Fritz, can you please mute your...
Okay. Anyway, I didn't know what it was, but I remember the texture of Ratetra. She was showing some of the, I don't know which work exactly. And it took me like, I guess, 5 to 6 years to understand what that was. Then, of course, I wanted one. Then I realized that they made only 20 and they're big and expensive. Then, in the meantime, I got into a project where my colleague built me quite a few vobulators, and that satisfied me for a while, but I was still haunted by idea of how to get that. And somewhere in 2012, LZX already came out, the video modular, but they were expensive, and it was of Muff Wigglers forums, I think. Yeah, on Muff Wigglers, Dave Jones was there, Lars was there, so we were exchanging messages, and I was curious about like how could that be done in audio domain. And as they come from video, they didn't know how jitter works in computer, and like in general, we're not so interested in video processing in computers. They said like, well, you don't have bandwidth for that. And kind of I thought maybe it's possible, maybe it's not. And it was sitting there for, I couldn't make it work until I broke my arm and finally got like 2 weeks or 3 weeks alone at home. And amazingly, it was working immediately, very quickly. I got the basic patch going. I was, of course, very excited about that. The thing was that it had much less resolution, but it was completely independent of analog video signals, so it didn't care for sync, for anything. Frame rate could be slowed down and sped up, which is kind of main feature, and also the number of scan lines could be changed dynamically, and in my own work with that, I kind of use that a lot, that it can go down and go up. So yeah, but I don't know, then I even don't know when was that, but I was thinking, okay, what other DA converters I have available on computer, and because the problem with sound cards was that you have to get a rather expensive sound card, and I was thinking like, what else could be done? I was also thinking like, how could I get finer image? And then I realized that actually VGA port is like digital to analog converter that almost all computers have, and that like we have 3 channels RGB. I was worried about sync signals and blanking and like how will that work. And so when I finally got to that thing that I want to, when I finally found time to test it, to try it out, it turned out to be very simple, because so we have the 3 cables, and the kind of theoretical part of it is very simple, and actually that's what you're looking. So we have like the classic deflection in both sides. There are some funny limitations, because like unlike audio signal that goes plus and minus, this VGA goes just in positive, so like it folds always to one dimension, and also if you move it like offset, like you you hit the brick wall on each side of it. It's not like in audio we can go out of the image. Here you cannot go out of the image. It turned out that because VGA is 8 bits, it means that we have we have much bigger resolution than with the audio-based solutions. We have 255 or 56 points on both axes, and the same for the brightness, which is great. And to me, the most interesting thing about this, actually the flicker that you see is because demons. I just hardly got this to work. Fritz, we were extremely lucky that like during the production of the movie, it was just ideal. And like I was trying to get the same patch with same equipment to work, and they are my witnesses. It was hell, and like image was all wonky, and like I was cursing. Like they said that I got Tourette syndrome during vector hack, which apparently I might have got. And but the thing with VGA is apparently the standard is very forgiving. It was long. It is old standard, so monitors were made to kind of recognize signals that are not in the same specs always. I'm not good with hardware in terms of I'm rather good hacker, but I enjoy like using software to control hardware, which is somewhere what this does. Obviously offsets and things like I should ask somebody. I hope that maybe we gain enough interest with this that we can find out like what are the parameters of the system and why it doesn't work occasionally. One of the main problems is that I'm just using normal VGA cable to you can't see it now, but to BNC, the old school cable that not many monitors are using today. And so my initial thought was just connect it to the oscilloscope, but the problem is that the computer doesn't recognize that anything is connected to it. So I was using video splitters or some simple devices that would simply say to computer, okay, something is there, go out. And the results were like, I obviously had luck, and apparently luck runs out the older you get. So, you know, like my attitude to technology now is like I don't expect any luck. It's just that part is gone, and like it's just despair, occasional despair. And so how does it work? Like basically on LZX or something, if you look at the ramps, which I never bothered to look, like the horizontal ramp is like horizontal gradient. Can we get the computer image now? If I think Arto, I think I might need your password, or like you can come here so I don't say it to everybody on internet.
Just yell your password out across the room, please.
1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. Can you play the computer image out? Okay. So here, and can you put the oscilloscope in picture in picture? So this is the patch. So what I was saying. So basically, no, the other one. Hi, Fritz. So anyway, until we get that, so the funny thing is, this is what goes out. This weird-looking image, because it's on red channel it has this gradient, on green channel it has this, and on blue channel it has brightness. So the interesting part is that it behaves differently. Maybe the easiest way to explain is like rotation. So actually, like, you can't see it really well, but on RGB here, like I'm rotating the image, but it doesn't rotate, it folds, like, because the beauty of this is that usually with Rat-Tetra systems you have to take lots of care of sync, of like how to sync all those signals, and with this is that whatever resolution or scan rate you choose, those three signals are always in sync, so you get those strange, also like if we zoom into image, so you can see on RGB again that we are that images on one axis zoomed many times. We just basically redraw the raster many times in one frame. It's it got me thinking a lot, like this, like what it is and how it works. So actually so I'm not talking about brightness. Brightness is kind of, it's always like what it's image. But these things, this goes to oscilloscope. But what it means to oscilloscope for us, we would say this is top left, this is bottom, right bottom. But to oscilloscope, this is beginning of the frame and this is end of the frame. So position in the frame is time. And what determines the position of the dot on oscilloscope, how it draws, is the brightness of the pixels. So the brightness of each of these pixels determines where the dot is, and position in the frame of the ramps is when it is drawn. So it's a bit mind-boggling, or a lot, and this is the basic system. Like I could manipulate ramps. Actually, I'm really looking forward to, like, this is like my favorite one for goofing around, like when my head shrinks and like you can get the stupid things out of it. Yeah, well, those are funny. Well, yeah, there are a few of those on my Facebook, but and actually, like, those are some Scanimate ads, like we're really using this, like making funny faces. Also, like, there is some nice, if I down-res the ramps, I can like do these things, and well, no, maybe other direction is better. No. Oh, I have to. Yeah, this sort of it just behaves differently. Like so one thing is simplifying ramps. The other thing is bit reduction, but lots of space to play around. Then what else before I get to really interesting part that has to do with this movie? So yeah, and you can play with gradients, and that's yeah. So Darko approached me for that he wants Rat-Tetra in this film, and I actually like proposed him that we could use audio, that we could use VGA, or we could use the real Rat-Tetra, which I don't have really a big system, but that we could, and that it mostly has to do with resolution. In the end, we opted for this system, which amazingly now I'm aware of worked really well. So, and now I'll jump back again. Early on in my audio experiments with this Rat-Tetra based rescanning systems, I was also playing with Kinect, and at one point I realized that, like, with Rat-Tetra, what we do is like we get 3D out of 3D effects out of brightness, which are kind of sexy but not really exact. But that Kinect sensor outputs depth map that is actually like brighter is I don't know what is if brighter is closer or the other way around, but anyway, like brightness relates directly to depth. So I made some experiments that works using that because of the lower resolution nature of audio-based systems and the fact that I didn't know how to rotate raster in 3D. The results were kind of not exactly visible in terms of like user experience, but I knew that 3D is in there, the real one. And when Darko mentioned that he will do the 3D renders of this imaginary theoretical architecture, I suggested that would it be possible to render depth maps too, so that basically we can try to do both. So I have one of the files from the movie here. Maybe we can make, well, can you make it a little bit larger?
I just asked.
Okay. So anyway, like now I'm doing the normal. No, I'm. I'm not sure which one. Wait. Of course, some. Oh, I know. I mean, this is production patch for movies, so. So yeah, this is the normal Ratetra thing that you get. It's you know, it gets distorted in this way. But now I have a little crossfader here in this area that basically can crossfade between. This is depth image on the left, and the RGB is on the right. It's a bit dark, but that's how it works the best on oscilloscope. So if I crossfade it, then we get like the real depth. It's kind of dependent on brightness and contrast in a really strange way. I guess some of the programmers here could like guide me to how to actually do a proper mapping of depth map to values in Ratetra, but playing around with brightness and contrast brings it pretty close. So yeah, and that's it. I mean, I find it fascinating. Sometimes it would be even better if I could rotate the whole thing but the math is really way beyond my how to do it with the image that is just in Jitterland. I don't know how to do that, so maybe that's for some future project. But all in all, we we spent lots of time playing with that, and maybe some more things to say. What I find interesting about this system is also that it shows both its obviously analog nature, because it comes out with this really non-perfectly standardized output from the computer, but on the same time, like for example, if we at some points we were reducing size of the image, and then especially in vertical, you start seeing I don't know is it aliasing or is it what I want to say, you can match values so that basically you get kind of nice looking scan lines that are well aligned, but it's all about ratios and how much lines you have. I didn't sort out the math because I just do it experimental way, but yeah, now it's the part of my presentation when I get lost and can oh yeah, Arto. Okay, but yeah. I mean, I was okay. I was. That's basically a bit out of the scope, I was using this quite nice software called Châtaigne. I don't know what's the French word for like the thing you eat in the fall. Châtaigne. No. CH. Okay, wait.
Quick Google search.
Châtaigne. Châtaigne. That's what's on the screen. So actually, it's like timeline app for. It has OSC. It's free. It's like amazing. It's not the only one that does it, but we use it to actually sort the timeline problem in Max because it's the whole other problem. But yeah, it's not so relevant to our theme. So this is it. I mean, I think I managed to mention all the things. I probably didn't prepare well for the. Also, yeah, one of the really funny things is this dot in the corner. It's actually blanking because on start of every line, the values of all channels go to 0. So the scan lines jump there, and maybe there is some way to do it with modular, to cut off the brightness, or something else. But kind of that's the nature of this thing. And so basically, what I wanted to say that what I like about the system is it has artifacts of its own. It obviously has lots of daemons, and that I have to sort out because, a few months ago we did at least 10 sessions or something like that with this, and image was always stable in the middle of oscilloscope, and now it's hardly. I had to move all the buttons, and I mean, almost it didn't work. It was just like, you can ask everybody else. And so yeah, it needs more work, but it has its own character, and you obviously cannot mess with frame rate. You can mess with scan lines. I think it doesn't sound well. I didn't test, but it's because the speed is always the same and rather high. I don't expect miracles, but then again, I didn't try, so who knows. Thank you very much, and until next time.
A report from Monse that chestnut is the word that we're looking for in French.
Yeah, chestnut. Thank you, Monse, and hello. We miss you.
Thank you so much, Klif. Thank you so much, Darko. Somehow, somewhere, we have crept dangerously far into our schedule. So, in the interest of trying to get somewhere back close to where we need to be, which is about a half an hour off, please let's take no more than 5 minutes, which is exactly 0.23 Croatian cigarettes. But seriously, 5 minutes and we're going to start again. Our next presenter will be Arto Chydenius. Welcome back to Vector Hack number 3 in Šibenik, Croatia. I'm going to try the sports announcer voice now. How do you think about that? No. I'm going to introduce our next speaker. Our next speaker is Arto Chydenius. He is a Helsinki-based software engineer with a special interest in the technology and visual aesthetics of the past. After pursuing a promising career in the software industry, Arto has recently taken up studies at Aalto Media Lab in Helsinki. His personal interest is especially in three-dimensional vector graphics, familiar from the arcade games and movies of the 1970s and 80s. And he's going to present his project called Voltage. I pass it over to you, Arto.
Do you hear me? Yes. Yeah, so the topic for my talk is voltage programming library for teensy microcontroller, which is somewhat intimidating maybe, but the idea is to create software for these really, really small microcontrollers for creating oscillographics. And perhaps my path to the subject was a bit different than most of the people's here, since I kind of stumbled upon the concept when I started learning Arduino programming a couple of years, or maybe 2 years ago or so, and like I saw on the internet that someone had connected an Arduino to an oscilloscope and drawing all kinds of shapes. So that's kind of where I got interested. And also, as already mentioned, I'm quite interested in the aesthetics of, especially of the aesthetics of 70s and 80s computer graphics. So also these microcontrollers are relatively low power, or they don't have much processing power. So like programming them is a bit like going into a past and trying out the solutions that people were using to do computer graphics in like a couple of decades earlier. And also later on, I saw all the cool stuff that most of the people have been doing here. But since I thought that the microcontroller approach it's somewhat different than like with using a high power laptop and a dedicated audio interface, I decided to kind of continue on my path, since from engineering perspective, I also got quite curious about the subject. But yes, so my idea, since I first saw that you could do these graphics on small microcontrollers, I was kind of, this type of graphics was on my mind. That's, for example, John Warnock, one of the early computer graphics scientists. I think that looks really, really nice. Both the display and the graphics rendered on it. And then I also remembered all the stuff from the 70s and 80s movies. For example, the Larry Cuba's Star Wars scene from '77, which is kind of, it still looks great, even though it's like line only graphics. I think it's only drawn in one color, so there's no even that much of any kind of brightness modulation. And some of the stuff I was also interested in was for a brief period, these kinds of vector displays were also used. Well, we all know Vectrex, but they also have been used in these arcade games. For example, this one, the Battle Zone from 1980. That's also probably the first game to feature like three-dimensional real-time graphics. So a bit about the method. So basically, how this stuff works is, instead of using an audio interface and pairing that with a computer such as a laptop, you use the plain microcontroller and get the audio signal or suitable signal out from that, and just connect that to a vector display. It's plain and simple. And what I found out by doing some tests, it works really well for solid and clean lines. And as already said, the method is actually it's quite similar to what was used in the 70s and 80s. And also, as we will see a bit later, there have been some projects which I was inspired of, especially like in the DIY hacking communities and retro gaming communities. And bit more about the concept. Like going through some of the existing solutions, there have been two primary approaches. Like first is that you have only the microcontroller which does everything, all the kind of the calculations of the graphics, and then converting them to voltage signal. And then there has been another solutions in which the microcontroller works only as a kind of a graphics card. You connect it to a computer, and then the computer does all the calculations, and then it just sends the line data for the microcontroller what to render. And you can use internal or external digital to analog converters for this stuff. For example, I'm using the Teensy 3.0, which is really low cost, nice microcontroller that costs like 20 euros, I think, and it's got 2 built-in DACs. So the only thing you have to do is just to plug it into a scope, upload software into it, and you're good to go. And also a bit about how the actual drawing is done. I'm not going to go into too deep technical details, but it's basically drawing kind of pixel by pixel. You take the starting point and you take the end point, and you kind of draw every value in between those, kind of that yields to a nice, really clean lines. Even though it takes quite a lot of CPU time, so you can draw less, but the result is quite nice. And it's also quite interesting that for example, in my library I used this line drawing algorithm that has been invented in '62, and it's still kind of valid stuff. If you play around with stuff like this from technical perspective, it's really interesting to see that there are many concepts that have been developed in '60s or '70s and they are still valid. But since all the new hardware is so fast, you don't have to think about those. I could quickly show two projects that were kind of inspiring me. There's this teensy graphics interface, which was published in Nuts and Bolts magazine. There's all the basic stuff described, but this is actually pretty similar to what I have done. So even though that there's a bit more electronics involved, like all these amplifiers and whatnot. And the other project is VST by a guy named Trammell Hudson, which is quite impressive. It also has a custom board and some custom electronics. And I think this was originally made so that it could be used with say these arcade game emulators, so that you run the emulated arcade game on your computer, and then you output it via the VST to oscilloscope. So you could effectively you could play any of those old games on a kind of a real display. And the last one is mine. It's at the moment it's only in GitHub, but it's got technical documentation as well to some extent. So if someone feels that it's is okay of writing some Arduino code, it should be quite easy to start working with it. Let's see. Yeah, some pointers about my software. I think to me the kind of the most important thing was to make it, if you know programming, but for example don't know that much of electronics, my main idea was to make this easily approachable. So, for example, starting with voltage requires you only to have kind of just a simple breadboard. You put the teens in there and then connect it, and then connect the wires to a scope, and that's about it. And I also made some experiments with using an external DAC for controlling the brightness. So if you want to modulate the brightness or have a bit nicer blanking or whatnot, that's also doable. But you can start with just having the controller. And this is about how it looks. And I was thinking of showing a code, but I think a demo would be a bit nicer. Just a second. Yeah, we saw some cubes yesterday, so I was thinking of showing some more of these. Can we have this one and the yes. Thank you. So I don't go to that much detail in code, but just to show a bit how it works. So it's basically by initializing the software, then creating some meshes, say a cube like this, and then creating objects out of them. Objects are kind of instances of the meshes, so you could have multiple cubes. They share the same shape, but they can be moved around and so on. And then you need to have a camera in a scene, and you can move and rotate the camera and whatnot to suitable position, and then you just add the stuff you want to render, and then call render. Now we have for example, in this case we have a camera looking at the cube from a distance of 5 units, and the object is like in the center of the scene without any kind of rotation. We could, for example, then for example, add some animation to it and send it, like upload it to the microcontroller. But how the thing essentially works, it's like as it is a programming library. It's kind of a collection of code. You need to sort of add code using the library in order to create like more interesting stuff. For example, here I've written code that creates essentially a sphere that gets modulated by a sine wave. And some other applications that could be used, or that might be good for this kind of setup, is to have kind of some kind of system. For example, here is a relatively simple thing done with just lines going that are programmed to go like along sine and cosine waves, but you could add a controller like of any sort, so you'll be able to modify them in real time. And I think one thing that would be actually a really nice match for this is to just have a program like this, and then you could add some knobs directly on the breadboard, and it doesn't need anything else than besides plugging the power on. You could do a sort of a standalone video synth or oscillographic synth with it. Let's see if I think I had one more slide. So to wrap it up, I think this sort of thing might be a nice match for, say in a situation where or say if an installation needs to run for long periods of time without uninterrupting. So it's in a sense nice that these microcontrollers are so simple that once you've uploaded your program, you just plug it into power, and it runs kind of forever without any sorts of problems that you might get when using laptops or so. And also one thing I've been thinking, especially here, since I've seen people have all kinds of these really nice modular synth setups. It would be nice to try out to create a simple module, drawing something like the small demo I programmed with just few parameters and see then route it to a kind of modular synth for messing up the signal a bit. And some of the other findings is that actually, since these microcontrollers are super low level and simple, it's quite like tedious and time consuming to program them. So I've been kind of thinking how about making some kind of ready setup and then build some sort of interface to say PD or something, so that you could do all the sort of interesting stuff on a laptop, and you would then just connect the laptop into the voltage. And I think some further hardware findings are so that these microcontrollers are at the moment, they are a bit slow for this type of stuff. If you would like to render more complex stuff, like for example these polygonal shapes that have like really big complexity, of course the $20 device is not going to cut it. But then again, for example, the latest teensy is something like 10 times faster already than that. So in that sense, I'm expecting that within a couple of years, these devices are able to do a lot more. Yeah, and one more thing is that in terms of audio, since the frequencies are somewhat low, so that's not especially interesting, especially when kind of the lines are drawn by writing really many values in between. So it's usually the audio is just sort of bit wonky, low frequency sine waves or something like that. Yeah, but I think that's about it. Bit different approach but it might make a nice addition to the tools, especially if refined to some bit more user-friendly direction. Thank you.
Kiitos. Kiitos.
Kiitos.
All right, great. Thank you so much. That was a great presentation. It was very packed with information. It was very succinct, and I really like the analysis at the end where you think about some of the future possibilities. Some things that crossed my mind, and also some people in the YouTube as they were watching. There are actually kind of patcher programming environments for the teensy that might appeal to people that aren't so good with writing this kind of text code, like C format code or Arduino format code or things like that. So that could be one option. I'm very aware that the number of objects in that patcher language are kind of primitive, but that could be one area to explore.
You mean like similar to, for example, the audio library that has the...
Yeah, where you have like on-screen primitives that you can kind of, connect things, you can draw the patch in that sort of sense.
Yeah, that's a good idea, and actually I think that should be quite easily doable as well.
Great. I like very much the idea, and also our viewers on YouTube love this idea of making kind of a standalone thing. I like in particular the idea that because they're so cheap, you could simply make a bunch of weird little generator modules and stick them into all sorts of other environments. I think that's really exciting. One question from Chris King. is about whether or not the Teensy has an analog or digital input that could be synced to video frame rate.
Actually, I'm not sure about that, but I think people have been using Teensies for at least with some add-on chip to use like to combine it with microphone input or some other types of input. So probably doable, but or of course doable, but not sure if that can be done on, for example, the Teensy that I'm using at the moment.
Okay, great. All right, thank you. Do we have questions from our audience here in Šibenik? Yeah. We're running as fast as we possibly can. You see me, I'm running to Joost.
No, I think like one of the things I really liked about your presentation was the going back to these historical sources and what you said about these historical drawing routines actually still being relevant for this kind of stuff now. But I was mildly shocked or even disgusted when you talked about this raster-based drawing routines. I was like, oh, like I thought we were in vector land and we don't need this stuff. So, so can you say why that was a good idea back then and why it's still a good idea now?
I think today, since computers work on distinct values and oscilloscopes work on voltage or continuous signal, I think these days, when, for example, digital to analog converters are so cheap that they are in the same time they are so precise, it doesn't, in practice, it doesn't make any difference if you compute everything inside the computer with discrete values and then transform them to voltage via DAC. But I'm actually not sure why they were used in the 70s and 80s, since, for example, Vectrex has a system that all the computation inside the computer is that's like ones and zeros and like discrete values, but it has these analog components that take care of the kind of the smooth lines. But this kind of DAC setup was also tried out in 80s, but during that time the DACs weren't kind of accurate enough. So even though you had a nice vector display, you had these jaggy aliasing problems, which is kind of I don't know why they were used at the time, but I think like during that time it was mostly these are they called integrators? I think, yes.
Great, thank you. I hope that addressed your religious concerns, Joost. All right, we are definitely at time. I'm going to summon a massive round of applause for Arto. I'm going to summon the wall of emojis to fall within YouTube. Perfect. And I'm going to let us know that we are we're quite a bit behind time. So I would very much like that we could also just take about a 5-minute break, and then we are going to get like a machine gun slideshow from Duff. So 5 minutes. I'm not even going to think what percentage of a cigarette that is anymore. Just don't smoke because it's not healthy. And we'll be back in 5 minutes. Welcome back to Vector Hack 3 in Šibenik, Croatia. We have one final presenter, and due to time constraints, perhaps a very microscopic panel afterwards. Let's see how things go. I would like to present a man who perhaps needs no introduction, Andrew Duff. In 2014, Andrew Duff collated and shared sacred information on how to modify a 1982 Vectrex games console to add 3 audio outputs from a modular synthesizer and draw pretty pictures. This simple act threw so much gasoline on the eBay bidding wars for Vectrex consoles that the fire is still burning hotter than ever. Apart from starting such trouble, Duff also teaches graphic design and digital media, ran the Brighton Modular Meet, which is now unfortunately no longer. He DJs, and he performs live audiovisual works. He is going to talk about the appeal of the oscillographic image. Welcome, Duff.
Thanks. I need to stand up just to deal with the adrenaline for this. Thank you. I've got a bunch of slides. You can hear me okay, and this kind of thing. All right. So we like oscilloscopes. Real ones as well as one on computers, and they have some kind of magical qualities. There's some of those qualities that they might have, and it's enjoyable to deal with those qualities when you purchase one or when you come across one. And I've got various examples of things that I'll show you as we go. I was having doubt when I was getting these slides ready. I thought, is this right? Is that the right thing for in these oscilloscopes? I couldn't remember. I've used this slide before in some other presentations anyway, so maybe it is right. I don't know. So one of the allures that these sorts of things have is going back to some 50s, 60s, 70s kind of things. We see these sorts of images in all sorts of situations on eBay, where you might find a catalog available on some website where you can see some old pictures of some cool stuff that turns out to be an oscilloscope. But what they are these weird but tangible relics, I think, because like, who uses a digital scope, a hardware digital scope to do oscillographics? No, I've had a go. It's not very good. But they do stuff, they behave in weird ways, and they're old, generally speaking. So they've been superseded by these digital things that maybe are less good. And I'm quite interested in the fact that they are superseded. I don't want to talk about media archaeology. There was quite a lot of discussion about that at the last one of these, wasn't there? So I don't need to go into that. Good. So that's 15 slides that I can skip. Well, actually, yeah, you can have a look at that book. But my main thing with these sorts of old pieces of hardware is this. They still have something to offer, and I think that a lot of you believe that kind of thing as well, that you can still do stuff with them. They have some inherent qualities that are useful and good, and that's fine. And this is another thing that, to do with the media archaeology stuff. We can use old stuff and we can use new stuff. It is really interesting hearing people talking about computers to do things with oscillographics. I've been a bit, like I'm physically doing it, bit walk away from computers for oscillographics because I use my computer a lot for doing my teaching, and I don't really want to do oscillographics on my computer. But maybe I do because of certain things that some people have shown now. But anyway, so we can use some old things and we can use some new ideas to hopefully create some new stuff. We can put some of ourselves into the things that we make, and hopefully that's good. Another thing with, I don't want to talk about media archaeology. Another thing with media archaeology is that we can reassess old ways of doing stuff and recontextualize it now, and that's good. These old beasts, we can help avoid landfill and dealing with the burning planet that we're all on as well. So, you know, let's keep these things going in one way or another. I think that's important. And then also using one of these sorts of devices, like I'm looking at this thing here, you've got to invest quite a lot of effort and time and energy into understanding it. You know, you'll sit there and go, well, I don't understand what's going on with this thing. So you're invested in the physical thing itself. You've got to carry it somewhere for a start off. You've got to plug it in. You've got to deal with some, I don't know what these things are that are sticking out the front of it. And that's an important part of it. Another important part that I feel I wanted just to cover briefly at the beginning of this was the aesthetics of the machines themselves. And I'm just going to look at Tektronix quickly. So like that logo is cool, and then the top logo is pretty cool, and then the other logos are not so cool. And then maybe this bottom logo is all right. Yeah? But they started off, and it was very much of a time and an era, and it carried on being very much of a time and an era, and then, I don't know, it went 90s or something, probably not so good. But something that I think is embedded, I think that's on another slide, yeah, something that is embedded is the use of particular aesthetics within these sorts of objects. Arto, it was interesting, where's it gone? The model number on that scope that you had a photograph of, it was using Euro-style bold. That's the typeface of the future from quite a long time ago. And it's on, you know, it's here on the Tektronix logo at the top, this blue one. It's loads of model numbers on things, and that's good. That's something that we've just, if you've watched loads of sci-fi films and stuff like that, like it's just been there. These things have just, they've been in our lives for ages, and that's great. These images are stolen from the Tektronix website, where we can see some tech scopes just used in various things, various film situations. One of my favorites, THX1138, they're not on, but you know, they're looking at them. Silent Running, Bruce Dern, same birthday as me, except I'm a bit younger than him. And Columbo, an amazing episode of Columbo, of all things, with some oscillographic stuff in it. It's cool. So they're there. Used as props in films. This was the result of some kind of hoard that I managed to pick up off eBay I think it was pre-COVID. Went to someone's house because I'd seen on eBay they were selling this bootload of oscilloscopes, and there was two that I really wanted, and I had to take all these other things, and then I just methodically cleaned them up on the outside, not on the inside, plugged them in to see whether they would work or not, and this lot didn't work, so I put them on eBay, and some bloke came and bought them, and I asked, why do you want all of these? He said, oh, for props, for some films. Oh, that's really interesting that I can take this stuff and feed it back into that kind of thing. So that was good. All right, what else is cool about oscilloscopes? They have this nice warm glow. I thought I'd do hashtag P7 tube. Honestly, when you lot were talking about P7s and all of this, I was just sitting there going, I don't really know what they're talking about here. I like not knowing, so you've taught me something. I had to go on the internet to find out. But anyway, yeah, so the phosphor inside the tube gives us this kind of thing, and this persistence of oscillographic image that we have this persistence of image in our brains as well. So that's good. That might be some part, I don't know whether it's some sort of warmth that comes through with these things. Now here's me just flexing on some of the scopes that I've acquired over time. This is this ridiculous wave tech thing that's about as big as a microwave oven, and I was really happy to get hold of that. Here's some other scopes, but can you feel the warmth? Can you feel warmth? Yeah, it's kind of warm. Also, they behave differently. I tried these little experiments where I just stacked up a bunch of my scopes, sent the same signal into them all just to see what would happen, and you can see, I know that they run at different frequencies and all of that sort of thing, but I don't know what they are, and if I did, it would probably spoil my way of dealing with things, so that's just me. But you can see that they're behaving in different sorts of ways. All right, that one's patched the wrong way around, so it's there. But there's different brightnesses, and there's different curves to the lines and things like that, which is good. You scale the voltages differently. With the wave tech thing, one axis, you have to really amplify it to get things to look, well, like to make a circle and stuff like that. And that's what happens with these things. One of the scopes that I found was this Leader LB09D, whatever it is, O2. So write that one down if you want to try and find a Leader scope to not be a Vectrex. It's a, is that a piece? Whatever the phosphor is in there. It's a nice big screen, similar size to a Vectrex. It's landscape rather than portrait. Runs a slightly higher resolution image, so it is a bit sharper. You do get more sparkly corners on things. You know, so the softness that we would have on this Vectrex image is it's smoothed out. So before, what did I have? Hang on a minute. Oh yeah. So there's various different scopes that I thought I'd put on the screen here, just to show a sort of a range of the different kind of speeds of phosphor, and they have some of them have this decay that you know more about than I do with the P7 thing. This one's broken here. I've got a picture of it being broken. I think this one's broken. Maybe this one doesn't power up. This thing is a bit of a pain to patch up and get working, but it looks amazing. So we've got this after image kind of thing that is the residue, the afterburn. It's interesting seeing the laser stuff and seeing that after image that gets left behind. What's happening with that? Like, is it really lighting up the wall that it's being projected on, or is it lighting up something in our brains? It's probably the brains bit. Look, here's the list of the P's. You can get this off the internet. I'm not going to go on about it too much. But look, and then also with those things, with those P's, there's all these differences, the color differences as well as the decay. And these two pictures are this one picture of the two stacked on top of each other. I just wanted to see how they would behave next to each other. Since doing this picture and little experiment, somebody explained to me about different sort of scaling settings inside the Tektronix scopes. Anthony Elliott, he was saying, oh yeah, you can get inside and you can tweak some of the settings to make things bigger and smaller, and I daren't touch those things because, you know, you never know what might happen. But another kind of lovely effect that we're used to seeing that we enjoy is this rotetra sort of thing. So I tried to see what that would look like on various different scopes. This is this giant Hewlett-Packard, well, it's not giant compared to some of the giant HP scopes that some people managed to get hold of. This is a reasonable sized HP scope, and then I managed to run, obviously it's not the same picture, on that 900 series Tektronix thing as well, and it's lovely to look at, isn't it? Here's the one that broke. So this was, I went to do a talk somewhere, and on my way home, something must have happened. Oh no, I've not got the right thing. Oh shit, hang on a minute. I can't see. Play. Sorry. Yeah. Get used to this. It's slower in here. There we go. So it's a storage scope, and I don't know, I think it was in the back of my car, and I was listening to some jungle, and it was really loud, and the bass just, the magnet from the bass just ruined the way the scope worked. I took a few photographs and put them on something. Jost suggested a particular Facebook group to have a chat in, and it did this for a bit, did the going around thing for a bit, and then stopped working altogether. And now it's a spare, like I'm going to take bits out of it and put them in another one. It's a giant paperweight or something. Right, so other uses of phosphor. You've seen some of these things. Robert Henk's laser stuff, which was a UV. Cheers, Philip. To project onto the phosphor, so the powder, the actual stuff that would be inside the tube, and Alberto's stuff, projecting the laser onto something, and then also just lasers on a wall. Yeah. Bernhard and Robert on the internet. So we can see that. Oh yeah, and projecting lasers into water. Who'd have thought of that? Do they? They regularly do lasers into it. All right, so a little bit of I don't know, maybe theory, something that I've been thinking about for ages anyway. Some of us like old synthesizers and the sort of warmth attached to that, and I think that these oscilloscopes have some kind of warmth as well. And Roland Barthes wrote about this grain of the voice in the early 70s, and another book that I read was talking about warmth and the grain of analog synthesizers, and I thought, oh yeah, well you can kind of talk about this in relation to oscilloscopes. They have a physical grain, the phosphor inside them, and then it will do whatever it does. And so, like, if you don't have an old scope, do you want one for the warmth? That's my question. Maybe you do. Not because they weigh not very much, because they don't. But also there's these other qualities that perhaps come from the age of them, you know, the fact that it might just break or whatever. That crazy phosphor list is that they do some other things, some other little unexpected things, the bit of jitter and flicker and warmth and wobble, or you send in a bit of another signal in by accident and it is doing something odd, and that's kind of good. Other sorts of grain in these images, and when I went upstairs at the venue in Zagreb, I was looking at Philip's photographs. Oh, wow. We've got the grain. So we've got the grain. These were from a laser projector, but on canvas, and so there was an emulsion painted on, so that's going to have its grain. Then there's the laser with the lights that's going to have a grain. And then I had to zoom in to look at the actual grain of the canvas itself and see that, and I just thought, oh yeah, we're getting quite deep into what we're looking at here. I enjoy that kind of thing. Also, we were witness to new grain. When Louise was showing the Tales from Beneath the Sheets. And I guess we're kind of used to new grain. I made that one up. We're used to new grain because we have to deal with digital stuff. Well, I'm going to share my cool oscilloscope pictures on the internet or whatever. And so you put it on your phone, you put it on Instagram, or you put it on YouTube, and the compression algorithms just give it that new digital grain. And so here on the left-hand side, this was just taken, sat over there. But on the right-hand side, I just thought, oh, let's put it into Photoshop and just turn up some of the stuff just so that we can really try and bring out some of that digital stuff that we wouldn't normally see. But it's there, and I think that's something to contend with. It's been interesting over the years, turning up at places with the Vectrex and people sitting there watching it going, oh, wow, that looks amazing. Yeah, it's really difficult to capture and to show digitally on the internet. Like, I think the laser is the only other comparable way really to take it, you know, into a space, right, apart from like sitting in front of this little screen to look at it. So we have to fall back to the joy of the digital and new grain. All right, 17 minutes, that's not bad. So hang on, I'm gonna have a little sip. All right, so yes, I've been talking about things that the physical things that we look at, and externalizing this sort of thing physically in front of us here, the aesthetics of those things, whether it's on them or the screen. And I think this is quite an interesting, this is probably like middle-aged man, COVID lockdown, bit too much time on his hands to think about stuff. But this sort of stuff. So we've all got these. We look at the thing that we're looking at. I am no expert. We're looking at the screens. We're looking at the wall when the laser's on it. And I became a bit more interested in maybe what is happening when we look at oscillographic images. And I semi-alluded to it at the end of my talk, the first vector hack. And so being asked to do this, I thought, oh God, I'm going to have to do this, and I'm going to have to look into it a bit more. And so I did. So, yeah. All right. So I talked about Flickr, William Burroughs, and Ian Somerville and Brian Geison's Dream Machine thing before. They took some ideas from W. Gray Walter, a cybernetic person who wrote this book in the early 50s. And he was looking at Flickr and what that sort of thing might do. There's a picture of a whatchamacallit, a strobe light. Yeah, and so different sorts of frequencies might get your brain to do different things, or you'll be relaxed or more active and stuff like that. And the science of it, I don't know. But he talks about it in that book from then, and they got into it. And it's interesting that around a similar sort of time, there was Luposky's stuff, amazing oscillons, and so there was this sort of vision quest perhaps going on. Most of us have probably heard of Aldous Huxley and Humphrey Osmond, and hear their conversation about the term psychedelic. This book is, I haven't read it, but apparently it's the letters between the two of them, and Aldous Huxley is talking about taking mescaline and LSD and looking at strobe lights, or looking at strobe lights, but then the flicker happening, and what sort of effects those sorts of things might make. This fella, Heinrich Klüver, I thought he looked pretty dapper there. He wrote this book in the late 60s, but it was based on some other stuff that he was doing. He was experimenting in the early 1920s with mescaline, so from a cactus, psychedelic, and then writing about what he was seeing in there. Also, I thought it was brilliant that the font on the book is from the future. It is Euro style or whatever, but it's not bold. It's capital. And so what he saw were phosphenes, and I'm not in any way discrediting any work that any of you have done with oscilloscopes or anything like that, but we can see these sorts of things if we shut our eyes and press on them and things like that, and I've been thinking about this quite a lot, and I really like it. I saw some just circles the other night when I was tired, and oh yeah, it was cool. All right, so they were researching this kind of thing, and so what's your brain doing and seeing without you having an external stimulus to it? Yeah, and there was this piece in flipping heck, I can't see anything. Scientific American in 1970, written by Gerald Oster, which was all about. You can find this article on the internet. It's all about these phosphenes and what's going on with them. Basically, it's like an old piece of. Like a news magazine article. But these sorts of patterns would be the sorts of things that might be generated from flicker, from the strobe light, and or having your eyes shut, and then these new sorts of shapes that the brain starts to generate. And Klüver called these things form constants. And so these sorts of figures and shapes, like I'm looking at a load of them up on the top there, all those hats or whatever that are on the wall there, all these sort of spiral patterns and things that they're kind of fundamentals of how we see stuff. It could be that these are the first stage of how we actually see in our cortical processing. I don't really know much about how it all works. There's an interesting article that I did find which was looking at psychedelics and how they were trying to work this kind of stuff out, so that how you do actually see. This is retinocortical mapping, and so I mean that sort of image maps to these kind of things. I just think this is like the same sort of stuff. Yeah. So how your brain would then start to piece things together, and if your head is kind of extra jumbled up for whatever reason, then it's going to start making some kind of reality for you. In the same way, you can have a look at that for a sec. Oh yeah, so that's quite similar to some of these kinds of things. Yeah. So Max Knoll was this other person who was electrically stimulating his own maybe and other people's brains and seeing what was being produced through that process. Please don't try that. I think they probably had something on the tongue and then somewhere on the head. But these sorts of figures on the left-hand side, these are the form constants that would be appearing. And then those sorts of things map quite interestingly. You've got phosphenes and entoptic phenomena. They're the same sort of thing. But they map interestingly to prehistoric rock art, things painted in caves and on stones and things like that. People with a different sort of technology than what we're used to having. There's a picture of some sacred geometry in there as well. So I'm just putting a few things out as like this, and then this, and then this. I tried to do some of those sorts of geometrical things in that. The other thing is, I'll say this wrong, pareidolia, and trying to form symmetrical kinds of images in stuff, and then how our brains will then try and make sense of that sort of thing. Yeah, and so going back to this sort of stuff, going to here, trying to understand whatever it is that we're looking at and make some sense, turn it into a face or something like that. It's interesting seeing Jost's film yesterday. I was sat in the middle at the front just really trying hard to make sense of what I was seeing. It was a really interesting process to see what would form, and I think perhaps lots of us saw the same sorts of things with bits of grids and lines and things like that that came out of the chaos of what we were looking at. So this is my conclusion to, I can't believe I got through all those slides. This is my conclusion to the appeal of the oscillographic image, that we have the neural oscillations, our brains, sort of tempos, and then how that's being manipulated by whatever it is that we're looking at. We're looking at flashy lights, basically, aren't we? We're looking at things. If you start to slow your oscillations down, you can see, like, oh yeah, it's doing this, it's doing that. And then maybe some of those things are these form constants, and part of the appeal is that in here we can map, they're familiar, like deep down in our heads. This sounds like it's kind of religious or something. It's embedded in us, as well as the science fiction stuff from earlier. I've snuck in words, haven't I? It's embedded in there. And so then when you start to add other kinds of things, other elements into the oscillographic stuff, like symmetry and, what's the other word? Circles and squares, or making alien heads and things like that, then you're kind of tapping into stuff that's already in there. And maybe that's my take on the appeal of these sorts of things. And that's it. Thank you very much for dealing with that.
Amazing. Yeah, take the load off. That was a wild ride of lateral thinking. Thank you so much. It's also quite interesting that when I woke up this morning, the first thing that I found waiting for me in my electronic media device here was a gigantic story on the BBC website about a new implementation of a dream machine using flicker to trigger different sorts of optical patterns with eyes closed. Yeah, it's from the BBC. Yeah. Yeah, was that something to do with the dream machine project thing that was for Project Brexit? The Festival of Brexit. Oh God, what's it called? The Brexit Dream Machine. There we go. Sorry. So they were trying to kind of coax people into this idea of accepting Brexit by flashing lights on them. Yeah, hypnotize them. Someone on the internet will tell us what it's called. It was. Yeah, it's interesting to come up with some kind of new way of talking about that. Thanks. Yeah. The other association is that not too long ago I got to watch an interview with Stephen Beck, who is very well known for the direct video synthesizer and also the video weaving synthesizer. And one of his other projects was also direct retinal stimulation with like an electrical synthesizer to the brain. And what the anecdote that he told was that he had lots of sighted people try it, and he had this kind of a power knob on it, right? And he brought in somebody who was sight impaired, who had really expressed an interest to find out what they would experience with it. And he kind of directed this person's hand to the power knob and said, well, why don't, normally I wouldn't do this, but why don't you dial the voltage? And the guy, of course, cranked it up pretty far and reported some very interesting electrical stimulations to whatever was there. So that's the same sort of thing as the what's his name Knoll stuff with great. Oh my God. Yeah. It's so yeah. Somebody did try it at home. I'm gonna giving LSD to blind people and stuff as well, then, isn't it? Or other such psychedelics. No, this is not just this is research. This is it's important. All right, I'm going to run out with a microphone into the audience, and I'm going to see if anybody has any questions, comments. I think we're probably going to have to forego a proper panel at this point. Let's just make it a free for all. Who's got something to say? Yeah, this is how to shut up an entire room full of people. All right, talk now. All right, maybe it's been a long day, and it's certainly not for lack of intellectual stimulation on the part of Mr. Duff here. Are there any questions from the internet audience here? People seem to love your T-shirt, Duff.
Yes. Thank you very much. My mic keeps running out of battery. Thank you. Yes, I was inspired by a 88 acid record to basically bootleg it. I have a few left.
Great. Like I said, if we started up a panel now, we would go for quite a long time. I might just throw out what maybe I'll make a couple of quick closing remarks in regards to this and tie it back to a few things that we talked about already. If we could we pull up the image that I asked you? Yeah, here we go. Oh no, look out! It's media archaeology. It keeps creeping back up on us. I've used this image quite a few times, and we're going to look at it again just for a second now. So we've had 3 sessions, and in the first session we talked a lot about the history and in particular different people's work within that history, and to some extent their relationships with very specific machines that are very interesting to us now. And that was the first day. On the second day, we talked about software, and we talked about some of the utopias that are implicit in developing software technology for people to create media. Some of it is that, of course, it renders things extremely accessible, that people can really grab a hold of it and take it and use it for low to no cost. It runs on, normally, hopefully, on machines that they already have. And even if they don't have a fancy old oscilloscope, they might be able to have a software implementation of an oscilloscope and still be able to look at it. So there's some utopias that are packed into software for the users, that it's accessible. And there's some utopias for the developers as well. Every one of our panelists yesterday talked about the kind of benefits that they got from this wide possibility of dispersion of a software platform, because you can get so much feedback packed into that so quickly. So my question that I think this micro panel, anybody can answer at this point, and maybe we'll just maybe actually Klif can come and throw some microphones out into the world there. Would be why hardware? If, given that software is kind of, even if it's closed source, it's still easily distributable. And if it's open source, it's something that we can open up and unpack and look at all the time. Why would we choose then for a hardware implementation? The downsides would be that the hardware is, of course, extremely expensive sometimes. Sometimes it's quite inaccessible. It requires high levels of knowledge to produce if you want to make a piece of hardware. Oftentimes, more often than not, hardware is extremely closed source, and the more we move to these kind of hybrid analog digital or purely digital platforms, the easier it is to absolutely close a piece of hardware to any sort of reverse engineering. And all of those factors can make things very elitist. So what are the utopias for hardware? And actually, Andrew talked about some of them, and this slide also mentions it. This is a picture of from an article called Zombie Media by Josip Paraka and Garnet Hertz. And what they talk about are these kind of phases, this little spike up in the beginning. So we've got a solid line that represents kind of this adaptation of the consumer base. And then we have this dotted line that represents the interest of, well, what is it? Oh, no, actually, no. The solid line is actually kind of the influencers and the cutting edge people. And the dotted line is like your grandma and these kind of people that are the normal consumer base of things. And so you have this kind of bump in the beginning, like when something shows up at like, I don't know, like Ars Electronica or SIGGRAPH, or it just enters the market, or probably even before it hits the market, and like the super sharp, super probably wealthy people grab a hold of it and make these crazy things with it. And then there's this like huge bump in the hype. But then the minute that first bump in the hype goes by, then all those people are looking for the next big thing. And this kind of general consumer adoption of this stuff comes a little bit later, and it comes up much more slowly, and it tapers off much more slowly. And so what Parikka and Hertz are talking about is that you have this final kind of media archaeological stage where this media it's a zombie, it's kind of undead. You have all this old stuff, and as Duff showed us, it ends up in the landfill otherwise, but you have this mass of cheap stuff out there that's extremely well documented. There's been a lot of projects about it, and it's dirt cheap because nobody wants an iPhone 5 anymore. We saw an iPhone 5 sitting in an arcade game, actually in a truck stop on the way here to Šibenik, and I was really laughing. I was like, who would even play this game to win an iPhone 5 at this point? But somebody might, so. Yes, Klif.
But by the way, that graph needs additional curve going up again, because like our oscilloscopes, like the ones that are desired, are getting like crazy prices. So there is also, like, it applies to everything else almost today, that like collection market or second-hand market driven prices are again going up. And I think we as a festival, as a have actually, and we have this problem on workshops that within last 5 to 10 years that people have been doing this from this, like, oh, cheap, you can buy oscilloscope. We came to the problem that we run workshops where young people are required to spend like €1,500 on equipment, and that's where like all the scope software, pure software-based solutions like that can use hardware but also have visualization in software are great, because I feel like it's like unethical to sometimes to show these things without some way out, because it's it's kind of that's where we are at the moment.
Would you pass the mic to Joost? I'm gonna, and then we'll get to Duff. But I asked Joost if he might be willing to respond very quickly, and maybe just to the basic, the simplest question actually: why hardware? What do we gain from it on different levels?
No, I think it's an excellent question, and I think there's a few, I think there's a very practical reason, which is still, if I look, there's a modular setup here just on the table quite close to me, and if you look at any of these knobs or any of these cables, if you wiggle it, something will happen. And still, after I don't know how many decades of talking about human-computer interface, it's still the case that if you want to make your code interactive, you have to design an interface, and you have little knobs, and you can assign knobs to parameters. But here you don't have to assign. All these parameters are just open. And you can even, if you are a bit crazy, you can take a screwdriver and open it up and put your fingers inside the circuitry. So I think the physicality of this stuff also allows for a kind of interactivity, which in software just still doesn't exist. I mean, even, like after decades of Macs and interfacing, and, this stuff is all fantastic. But that sort of basic interactive problem is still not solved. You still have to predefine what kind of interaction you want. And I think one of the advantages of hardware is that there's a lot of interactions which are just available, at hand. So I think that's one thing. Another thing I find personally, if I look, I think one thread which ran through the whole few days here was this idea of the dialogue with the tools, and then, Fazulka had this idea of the dialogue with the tools, and then there's the dialogue with the demons of the tools, and then there's lots of people talking about demons of different kinds. And I think what I find really interesting about hardware is that you also reactivate some of these demons, so you can sort of like what Andrew was saying about, I don't want to use the same tool I'm using for teaching also to make my oscillographics. I think that's a very powerful point. You don't want to, computers are everywhere. And at some point also, you get physically sick of sitting there with a mouse, and you just want to have a different kind of interaction with the machine. So I think that's also one of the reasons you might want to use hardware, and also learn or sort of get involved again with the practices which surrounded this hardware, a few decades ago, and actually learn this stuff, like what, how, you have to focus the scope. You have to do all kind of stuff which you don't have to do necessarily with digital equipment. So for me personally, also like learning, for instance, all this analog computing practice, it's just also a way to rewire your brain and sort of reactivate a whole set of ideas which have sort of disappeared from our sort of consciousness, and also reintegrate them or bring them back. So I think that's another way to also think about like hardware. It's also kind of repository of past practices.
Wonderful. Thanks so much, Joost. By the way, Joost Rekveldt's PhD work is exactly about this dialogue with machines, and we've looked at his film now a couple of times, and as Andrew mentioned, there's probably, and as I've been saying as well, there's probably every kind of image you could possibly see hidden in there somewhere. So thank you, Joost. Duff, you had a response as well.
Is this working? Oh yeah, it is. I was getting really excited about the mature technologies at no cost point at the end there. You know, we've got ancient brain technology in here that I don't want to sound like a psychedelic evangelist, but I mean, you know, sorry. There's things. But what you're saying, Joost, as well about using hardware, like I would equate that with flow and that whole Mihaly Csikszentmihalyi act of doing, and how that sort of thing can take us away from endless scrolling, tapping, and that sort of behavior that is just a plague, and giving us those opportunities to do something that is more tangible. You know, that's my kind of beef with. Like, I love Max MSP and things like that, but it's, you've got to patch in some kind of physical controller to these things to make it work. But to get away from that sort of thing and to have something that you can do and that tangibility, that's really important. So it is, like we've said, it's a real shame that these technologies, the physical technologies, are becoming harder to get hold of just through financial things, and that's.
Great, thanks. Just to either Arto or Bernd have any quick closing remarks on this topic that you'd like to add to the mix?
Yes, I use the modular synthesizer because it limits the possibilities. I get overwhelmed with using a computer because there's infinite possibilities, and then I do this and I do this and I do this. Here, the patch somehow, you have limited possibilities. You have only the functions that are in the case. The downside, I travel with this quite a lot, and I do touring, and it's heavy. You know, it's like I would rather have like a computer and carry less, and don't have a back in my like a pain in my back. But it limits the possibilities, and then the patch somehow becomes an extension of your brain, which also it does in software, of course. But then just minimalizing the possibilities, or like finding like this concept of maybe a little less is more, and trying to, that's the way for me to go, like why I choose this tool.
Wonderful. Limitations push creativity.
Just a little note that I agree, but I think that limiting possibilities like valuable technique in creative work, especially when you hoard equipment. And in my case, like it applies the same to hardware and to software. And the best works I did is just like saying, okay, I'll use this and limit my tool set, because as young artist, as I was hoarding, like there was at one point like wish to use everything, which kind of just like you lose focus. And I think the same thing applies to software as well. So I think it's a valuable technique, but definitely not defined by hardware or software.
Arto, any closing statements from you?
Yeah, I was thinking the kind of the same limitation thing that, for example, I kind of enjoy really early minimalistic computer art, for example, and I think that's also of course at the time in kind of that trend was all in all popular, but I think some of the works have probably been born out of the limitations as well.
Definitely. All right, that is that. I'm gonna like we caught one of our panelists on the first day, like at the end, like the little hot mic moment, like fucking shit, wow. I'm right there too. Thank you all so much. This has been absolutely great. This whole cycle of things has been absolutely great. We're about to pack up, get out of here, and go play around with lasers and projectors on a several 100-year-old fortress wall, which is also going to be really fun. So, thank you, presenters today. Thank you, audience here in Šibenik. Thank you, audience online. Thank you, Klif, for doing this amazing amount of heavy lifting. Thank you to the volunteers that have worked with us on the Vector Hack. Thank you to Sarah, producer, who has been doing also heavy lifting and getting yelled at by restaurant owners across the entire country of Croatia because we're such horrible people when we get to restaurants. And thank you to the technicians who have made all of this possible. You're all wonderful, and I want to wish you all a good evening. Thanks a lot.
And thank you, Derek, for absolutely fantastic host. What's the word? Not hosting, but
Disrupting. I don't know.
no, leading the whole. Oh, I'm completely lost in words, but moderating. That was the word I was. Thanks for the moderating for conference. It worked excellent, and thank you very much.